So welcome everybody, and thanks so much for coming to Straight Science. So to start with, Straight Science is an evening science presentation put on by UAF Northwest Campus in Nome, and also UAF Alaska Sea Grant, and you're in the home office tonight. And both UAF Northwest Campus and UAF Alaska Sea Grant serve the Bering Strait region. We're public servants out here. And the Bering Strait region is the homeland and waters of the Yupik, Inupiaq, and St. Lawrence Island Yupik peoples. And tonight, I am really excited, as always, to bring give a warm welcome to Rick Thoman, who is really a returning member to Nome since he I think it was, you said you cut your teeth in 1978 with the Weather Service right out here in the Nome Weather Office. And we are very grateful to have Bering Strait in the radar, in Rick's radar. And Rick is the Alaska Climate Specialist for University of Alaska Fairbanks. And he is with the Alaska Center for Climate Assessment and Policy. And tonight, Rick's going to talk to us about the sea ice and the wild weather ride. And it sounds like we're not out of the woods as far as our wild ride. So buckle in, everybody, and save your questions, or no, don't save your questions to the end. Rick had said, feel free to sing out if you have a question, and we'll deal with that. And I will deal with whatever anybody wants to chat. Right in your chat, which is the bubble at the bottom of the page if you're on Zoom. And if we get any callers, which we don't have right now, know that callers will have the priority. That should be all the instruction you need. Take it away, Rick Thoman, and tell us what went on and where we're headed. Thank you so much.
All right, well, thanks very much, Gay, and thanks to all of you for taking time out of your Thursday evening to join us here on Straight Science. Always a highlight of my day when I can participate in this. So I am coming to you from Fairbanks. I work at the Trothier campus of UAF on the traditional and never ceded lands of the lower Tanana Dene people, and I'm very honored and grateful to be here. So it has been a wild weather winter in Western Alaska and really in most of the state, really quite dramatic. And so we're going to go through this with a focus on Western Alaska, Bering Strait region. And I do want to spend a fair chunk of this presentation on the sea ice situation in the Bering Sea, because to be frank, this has not evolved the way I would have thought it would have, given the cold start that we had to the season. So I think it's worth talking about, and I'm particularly interested if you have any insights into how ice has evolved in the northern Bering Sea. I would love to hear it. All right, so as I said, the wild weather, what's happening with sea ice, what's happened with sea ice, and then we'll finish up with the outlook for the coming season here, as we usually do here on our weather semi-annual weather review. So here's the timeline that I put together for Western Alaska weather. Obviously, could put a lot of details in here, but I tried to hit what I thought was the highlights. First significant snowstorm across the region, the first days of November, and that really set the stage for a super cold November. For Nome, it was the coldest November since the 1950s. Farther south, Yukon Delta, YK Delta, and down into Bristol Bay, it was the coldest November on record, and that really jump-started sea ice formation much earlier than we've seen in several years. Very dry, very quiet weather and cold weather after that first snowstorm for most of December. Big pattern change, though, the first days of December, that severe Bering Strait storm, wind gusts to 99 miles an hour at Tin City. Most of or all of the FAA weather stations, Gamble, Savunga, and Wales, they went out, whether they got knocked up or they got the communications went out. I don't know, but widespread 80 to 100 mile an hour winds in the Bering Strait and pretty stormy farther east from there. That just kind of set the stage for what was really an utterly remarkable second half of December, with just storm after storm, multiple rain of storms, high winds, heavy snow, really, really remarkable, not just across Western Alaska, as we'll see, but a large swath from the Russian Far East all the way across, actually all the way into the Yukon. Just an amazing period. That's the same event, of course, that produced the extreme heat, 67 degrees on the day after Christmas at Kodiak. As we went into the new year, the storminess calmed down a little bit, but there were a few intervals there with strong winds, particularly on the 9th. That was Gullivan had wind gusts in excess of 70 miles an hour in that storm. But that really just set the stage then for that beginning of February, just extreme winds across most of the region, but less so in the Bering Strait and on St. Lawrence Island. But this was the 3-day average wind speed at Unalakleet, 45 miles an hour, probably the longest, strongest sustained winds at Unalakleet since the 1950s. And that is saying something, of course. Unalakleet gets a lot of strong east wind. More rain the last days of February, and then, of course, the headline making strong Topcock area winds during Iditarod. Once again, not the first or the 10th time we've seen this, but really a high visibility, high impact winds there for Iditarod. Good to have Iditarod back to the coast, and the strong winds there, of course, are a feature of Iditarod. All right, so if you were with us back in October, you know, we had a La Nina winter this year. Means that sea surface temperatures in the equatorial Pacific, kind of east and southeast of Hawaii, were colder than normal. And whenever we have that, one of the things I always emphasize for Alaska is that we tend to get big shifts in the weather pattern during La Nina winters. And this winter did nothing to dissuade me from saying that. So here's a plot of daily temperature departures from normal for Nome on top, Unalakleet on the bottom. The blue bars are days when the average temperature was colder than normal. The red bars warmer than normal. And you can see that very cold November basically just stayed very, very cold, big departures from normal. But then once we got into the first days of December, that pattern changed that brought that big Bering Sea storm, a whole lot of flip-flop. And it wasn't just mostly just small departures from normal. It was either really cold or really mild very frequently. Overall, counting in the November, more below normal days than above normal days. If you just started in December, it's actually pretty close to a 50-50 split. But really big flip-flops. And that's really, to my mind, the feature of this winter, or one of the main features, was the dramatic changes, the repeated dramatic changes that we saw in the weather pattern across Western Alaska. Now, here's the precipitation. So again, starting November 1st, and I've plotted several things here. The blue bars are just the daily precipitation reported from the automated station at the Nome Airport. The dotted line is just the accumulated precipitation starting November 1st. And then the green line is to give you an idea. That's the normal. And as everyone is aware, really we packed up way more than half of the precipitation for the entire cold season fell in that 2 weeks in the second half of December there, with repeated heavy precipitation. some of which was snow, some of which was rain. The mix varied depending on where you were at, but almost everywhere got significant rain during that time. So significant icing, all capped off, of course, on the 28th of the 28th of December, 29th, with rain changing to snow, and then extremely strong winds, with those winds gusting to 70 miles an hour at the Nome Airport. It's actually the highest wind gust reported at the Nome Airport since December of 1977, I believe. And the power lines were coated in ice, and so a lot of power outages around town, all really quite remarkable. Both before and then especially after that, of course, it has been not a lot of precipitation across Western Alaska, but even still, we had one day with at least one day at Nome Airport with rain, and then repeated rain in the last week of February there. So really quite eventful precipitation, even as a lot of it got chunked up there in just 2 weeks. Maybe the other big feature besides the flip-floppy nature of the weather has been the winds. It really remarkable wind. We're going to spend more time talking about this. This is just the average daily wind speed. That's the bars here at the Nome Airport. The numbers there are the averages for the month. November average wind speed exceptionally low, one of the lowest for November average wind speeds in the last 30 years. On the other hand, both December and especially February were extremely windy. And you can see there's quite a number of days there when the average wind speed above 20 miles an hour at the Nome Airport. And in fact, if we ask, okay, well, how about days with average wind speed above 25 miles an hour? For a daily average, that is really strong for Nome. Okay, for Gamble, for Wales, not so much. But for Nome, that is really strong. And you can see we had more days, 9 days since November to March, with average wind speed of 25 miles an hour or higher. And that's the most in any winter going back into the mid-80s. So while the averages were above normal for the whole 5 months, maybe not dramatically so, but that threshold, that exceeding that 25 mile an hour threshold, so really windy days, last year had been the most since the mid-80s, and now even exceeding that this winter. So winds were a big deal. So breaking it out by months now for Nome, here just showing you precipitation on the top and temperatures on the bottom by month. The bars indicate the departures from normal. The numbers there are what the actual values were for total precipitation and an average temperature. So you can see, December dominates everything with precipitation. Every other of the other 4 months were all below normal precipitation, but December so far above normal. Similarly with temperatures on the bottom, way below normal in November, coldest since 1956. Otherwise, not that far from normal. January was significantly cooler than normal. Both December and February wound up very close to normal, but very mild March. So it's not quite the case that it all balanced out, but as we'll see, came pretty close, and a good lesson in when we add these things together. Sometimes near normal is composed of a whole lot of not near normal. Now, I mentioned earlier, and we talked about it in October, so La Nina. We have this winter again, just like we did last winter. That's not that uncommon to have back-to-back La Ninas. How did temperatures work out? Kind of at least traditionally, the rule of thumb is La Nina winters are cooler than normal across Western Alaska, but you can see that rule is kind of falling apart. Now, I have not adjusted the temperatures here for the trend, but I have used the second half of the 20th century here for my baseline, And 3 of the last 4 La Ninas have been warmer than that 50, in this case, 51-year average. So a good example of, just because we have some rule of thumb from back in the day, we need to continually update our thinking, because clearly, at least looking at core winter, a La Nina did not bring us a colder than normal midwinter. All right, so now chunking it into the big space here. So average temperature for November through March, the 5-month cold season here. Nome highlighted there. A bunch of these graphics here from our colleagues at the World Climate Service. And the way they do these, what I'm showing you here is the blue colors, the cool colors, are areas that were significantly cooler than the 1991 to 2020 average. That's our international reference period that we're using right now. So you can see Nome and the Seward Peninsula falling into that significantly below normal category. For Bering Strait and St. Lawrence Island, as well as kind of southern Norton Sound coast there, fell into that near normal category. The warm shades there are areas that were significantly warmer than normal for the 5 months here. So all in all, most of Western Alaska for the 5 months in the significantly cooler than average category. And that's really showing the dominance of just how remarkably cold November was. Now here's the precipitation again for the 5 months. So here, this kind of interesting. Most of Western Alaska falls into that near average category, because 4 of the 5 months were below normal, but December was so incredibly wet. In this case, for most of Western Alaska, it kind of did balance out overall, even though no one would describe this winter as near normal in terms of precipitation. For the 5-month totals, that's how it worked out. Notice we do have that first shade of green across eastern Norton Sound coast, eastern Seward Peninsula, southern Norton Sound coast. So those are areas that did fall into the significantly wetter than average category for the 5 months as a whole. You'll notice that stripe of dark green colors extending from southwest Alaska, and then especially across into the interior and all the way across the Yukon into the Northwest Territory of Canada. And those are areas that had the wettest, I should say they were wetter than any of the 30 years in our 1991 to 2020 baseline. So really quite an interesting pattern across the state for the 5 months. Now, I would be remiss as a climate person if I didn't put up something about December. I actually had to redo my precipitation scale here because it was so off the charts. So again, the green colors here indicate areas that were significantly above normal. In this case, this is just a percentage of the 1991 to 2020, our 30-year baseline. Nome highlighted there for you. And I want to point out that we've got 200%, so twice normal or more, extending all the way from northern Kamchatka across the northern Bering Sea, Seward Peninsula, right into the interior, and then all the way into the Yukon. Here in Fairbanks, we were almost in the middle of a large area with more than 5 times the average precipitation for December, and most of Western Alaska there from Nome east, more than 3 times the normal for December. Really quite amazing. It's not, sometimes with precipitation, we kind of see these big high values, but they're usually in very small areas. Not in this case, thousands of miles of just far, far above normal. Meanwhile, Gulf of Alaska, South Central, significantly drier than normal. And that's a result of that very stable pattern that we had once the pattern flipped right in the first week in December. Now, how about snowfall? For snowfall here, again, we're using our climate analysis model, courtesy of the World Climate Service here, who generated this analysis. And much like precipitation, shows up as near normal for the 5 months for most of Western Alaska. Interesting here that we do have an area there, eastern St. Lawrence Island, that did fall into the below normal category for snow. Now, you'll recall precipitation was in the near normal category there. That no doubt indicating a higher percentage of the precipitation was rain than is usually the case. And thought I'd finish up. Here's where we're at basically now. This was a snowpack relative to normal as of April 1st. Of course, we have basically zero water content and measurements anywhere in Western Alaska these days. So we are entirely dependent on this kind of computer analysis to get an estimate. And you can see, as you can see outside your own door, generally pretty close to the long-term average for snowpack water equivalent, at least for most of the southern Seward Peninsula, maybe a little bit more above normal farther north and across most of St. Lawrence Island. You'll notice that area there of way below normal snow from about Shaktoolik all the way south through the Yukon Delta, really the whole lower Yukon Valley. And that appears to be correct, just from reports we've heard and from the FAA webcams. There's a lot of areas there, or at least a lot of airports that you can see that there is not much snow cover, either thin or in some cases, it's just patchy snow. So that looks pretty real. It won't be an issue for a while, but eventually you'll notice those big blue numbers there farther east in the interior, and that 250% in the Tanana Valley. That water will eventually, of course, be coming to you as that melts and runs into the Tanana, and then eventually the Yukon. That water will be flowing into Norton Sound come this summer. So at some point, look for very high water levels in the Tanana Basin. This is by far the highest snowpack on record for the basin as a whole. So there is going to be a lot of water coming down the Yukon as we go through May and into June. All right, so more on winds. So here, what I've done is I've cherry picked and cut out the very low wind November. And so here we're looking at winds relative to the past 60 years, the average wind speed for December through March. And the purplish colors here are all areas that had significantly above normal wind speed for those 4 months. And the darkest color purple there means that this winter was windier than any in the last 60 years. And you can see that includes Norton Sound, southern Norton Sound coast, right in all of Western Alaska, with maybe the exception of right in the Bering Strait was significantly windier than normal. You can see there that Nome is in that third shade of purple, third from the top. So that's basically in the top 3 of the windiest December through Marches in the past 60 years. So it's not your imagination. It was really, really windy once we got past Thanksgiving. Okay, so that's kind of the review of where we've been. So now let's turn to sea ice. So here is my plot of this is the daily ice extent from the National Snow and Ice Data Center. The blue line is this year, the green line is last year. This is the entire Bering Sea, the ice extent. So it's a yes or no. Is there 15% or more ice coverage? Yes, it counts. Less than 15% ice coverage? No, it doesn't. All determined by satellite. Actually, I have every year since this started in October 1978 is plotted here. The mid value for the 1991 to 2020 period. So you can see that we had above that typical value for sea ice extent in the Bering Sea for most of the winter, not all. We did, with that change in the weather pattern in December, we had a significant dip that lasted until about New Year's, then a big climb, and then the big dip in February with another change in the weather pattern, but then some recovery, although still we wound up, the maximum ice extent was in mid-February. That's pretty early, not the earliest, but pretty early for a maximum sea ice extent. And now it's tailed off some, and over the next week or so, we're going to see big drop with another change in the weather pattern on the way. But overall, much more ice especially in the fall, and for the winter as a whole. This has been about the most extensive sea ice that we've had since 2012-13 for the Bering as a whole. So here's what the ice extent looked like. February 15th was about the maximum. These analyses from the National Weather Service Sea Ice Program in Anchorage. February 15th was the highest overall sea ice extent. And you can see the ice was through most of Bristol Bay. St. Paul was in the ice at that point, not to St. George, and then extending northwest to the Russian coast. Now here, just last week, a bit of a hubbub as the ice eventually did get down to St. George Island for the first time since 2017. Was only around the island for around St. George for a few days. The total ice extent, though, was not as high as it was back in February. You can see here on March 28th, most of the ice had cleared out of Bristol Bay at that point. So, but because it did get to St. George, that of course got some press. But it's since retreated back a little bit, although St. Paul has still got some ice around. So now I just thought I'd review some of the satellite imagery. All of these, if you're on our Seward Peninsula, Bering Strait Facebook Weather and Climate Facebook group, you've seen these. I made all of these and posted them there. So I just thought I'd take us down a little trip down memory lane here. So here we are on November 19th, and you can see most of Norton Sound is iced in at this point. It's, of course, this is all pretty thin ice, although there's obviously patches of snow-covered ice in there already. But the big thing here at this point, of course, was that there was ice, period. You'll recall in 2020, Nome did not have the first ice as seen from the beach until the first week in December. So big change from actually most years since 2012. November 19th, we even had, there was some slush reported, right on the beach there at Savunga, even though the main pack ice wasn't down there yet. So, so really it's a much better start than we've seen in quite a while. So it was looking pretty darn good in the middle of this cold November. Now, of course, that's about a month either side of the winter solstice. There's not enough sunlight. The sun's too low on the horizon to generate these nice clear sky pictures or these visible images. So now we skip ahead till to January 19th, just as the sun's coming back. You can see actually the limiter there on the imagery that cuts off just at Shishmaref there. So didn't have an image yet for Kotzebue. Sun was too low yet, but this was our first post-solstice look in the visible imagery. There's of course a lot of other imagery available for Norton Sound. And boy, this is looking pretty good. I mean, this looks like kind of what a good ice year, at least by modern standards, looks like. We've got, there is some cloud in here, but all in all, it looks pretty decent for Norton Sound ice. We've got ice past St. Matthew Island at this point. It's not to St. Paul, But all in all, this is looking pretty good. I mean, it's looking typical of what we see. Now, if we look close, you can see here, east of Safety, there's some thin ice here just beyond the shoreline. Again, that's not terribly atypical. Similarly, on the Chukotka side, there's some thin ice just to the lee of the land. Not unusual in any sense. Looks like a pretty good year. Now, let's jump ahead to early February. This is from February 1st. So this was the first day of those screaming east winds. And now we see some stuff starting to happen here that, hey, maybe something's not right here. So I've annotated here some areas of open water, and you'll notice distinct difference here in the quality of ice, say, Elam area here beyond the shore fast ice in Norton Bay. Obviously, that's much thinner, newer ice. Still have this older, thicker ice, older as in this year. Of course, none of this is multi-year ice in the Bering Sea. But do have some open areas here beyond the shore fast ice off of the Yukon Delta. That's not particularly uncommon. On the Chukotka side, we've got areas that had been open with newly reforming ice and open water or low concentration ice south of St. Lawrence Island. Individually, none of these things are terribly unusual, especially in the modern era, but collectively, there's a lot of relatively thin ice is starting to show up. Now here we jump ahead to mid-March. Now the sun's nice and high. We get good looks. March 11th and woo boy. Look at the different quality of ice. The colors of the ice is dark, thin, new ice here in eastern Norton Sound. Still have this thicker ice here between Nome and the Yukon Delta, but lots of areas of either open water or low concentration ice beyond the shore fast ice here. And these areas off of Chukotka and south of St. Lawrence Island are still there. Thicker ice to the south as those winds have pushed that ice continuously to the south. So this was by mid-March, of course, things were like, something's not right here. This was particularly surprising to me because it had not been particularly warm. There had been a few warm days, but into mid-March, temperatures were still running overall below normal, not dramatically, but it certainly was not another 2018 or 19 and super warm by any means. So, but clearly ice conditions were really not good in the northern Bering Sea here. And this is the same time the ice is pushed pretty far south. And so, oh, look, the ice extent's really good. Well, the ice extent, 15% or more ice concentration, that's all you need to count for ice extent, might be comparatively in this era high, but the ice quality was clearly not that in most of the northern Bering Sea. And here's where we were a couple days ago. I don't really know what to say about this. That almost all of Norton Sound that isn't shore fast ice is now thin ice. All of this thicker ice that formed earlier in the year has been pushed basically out of Norton Sound. And now we've got this thin ice, not just in Norton Sound, but now it's showing up way far north to, southwest of Wales here, even along the Chukotka coast here. Thin ice, there's some thin ice, open water here even showing up. Similarly, St. Lawrence Island and Chukotka all along here. You can see these thicker ice flows here, but there is a lot of really thin ice showing up. The thicker ice is all pushed, or not all, but most of it is pushed pretty far south. So that's a satellite view. So here now we have some aerial pictures. You may have seen these. This image courtesy of Gay on approach. There's Gamble in the top center there. She's on approach there into Gamble. And that is not the way that I think, that I expect ice will look in late March off of the west end of St. Lawrence Island. It's not that there's, oh, of course it's not surprising to see some water, but look at the quality of that ice. A lot of thin, dark ice. That is not thick ice flows bobbing around. That is a lot of poor quality ice. And again, why is that? It hadn't been like super warm or all this stormy weather, south wind stormy weather. So this is a still from a video that Gay has. So Gay, take it away.
Okay, Rick, we need you to stop sharing for a second. See if we can pull this off. And maybe you talk us through this. Here, there it is. Hopefully you can see it coming into Gamble.
Okay, so here we are on approach into Gamble, and I'll call your attention there to just look at the quality of that ice. There is some okay ice, but look at that thin gray ice. Not what you expect to see in March. If this was December or January, you might say, okay. Notice on the top, near the top of the image there, a nice view of the mountains in Chukotka, and really, it's not just, this is a narrow, thin area of this poor ice that extends across most of the strait. Now here we are lined up and on approach now, getting ready to touch down at Gamble, and look at that. We've got that. We've got certainly ice that you can't do much on. Really, as you'll see here, right to the beach. It's really, again, you know, when I first saw this, I said to Gay, you know, it looks like you're landing in Anchorage. That looks like Cook Inlet ice, not the St. Lawrence Island ice at the end of March when ice conditions ought to be at their best. Well, thanks, Gay. That worked, at least from this end.
Yeah, good. So you should be able to pick up where you left off if you share your screen. And while you're doing that, I would just say, as being the one in the plane, what struck me was I kept waiting to see the big ridging. There was no ridging. The plane's coming down and we could just see the water right as the wheels were touching down. There was no big ridging or shore fast ice. Normally, you know, people have to chop a path through the ridges to get boats through it or whales back up and other game. But it was just like that to the beach. Thanks.
Here's some other pictures that have been kindly shared from around the region here in end of February or March. This from Jeff Schultz, Iditarod photographer. This north of Unaclete, about the 15th. There's Besbo Island and open water just beyond this narrow fast ice here. Really quite amazing to see. From Gamble, the end of February, you know, maybe not quite as bad as we saw in 2018, with absolutely no ice in the water, but obviously this is really quite open water. And just from mid-March here, again, this is from the helicopter on the way to Diomede. There you can see in the top center, and again, this very low gray ice, looks really thin, does not look robust at all. And again, March 13th, this is not what we would expect. So sea ice thickness is one of the things that I get asked about a lot from the Western science side. And, you know, in the past, we have not had much in the way of tools to address that. Well, that is starting to change. We do now have, we have 12 years now of satellite derived sea ice thickness data. And so I would never recommend using that short a time for a climatology, for some average, but one, that's all we have. And two, sea ice is changing so fast that this might be just as good as, even if we had a much longer record, you know, sea ice quality, sea ice thickness from, you know, the 1980s or 90s may not really be a relevant measure anymore. So using the 11 years from 2011 to 21 as our baseline. This was what the thickness looked like the last week in March, the satellite derived. And any of the brown colors here are thinner than normal. Any of the green colors are thicker than that just 11-year period average. And the darker the colors, the greater the difference from that average. And you can see this very, very thin, low thickness ice being measured by the satellite in Norton Sound, going around the corner up towards Wales. Similarly, even to the south of St. Lawrence Island, the satellite thickness was well below the 11-year average. In contrast, thicker ice here, especially in kind of the southern Gulf of Anadyr here, and also north of the Bering Strait, not as dramatically so, but thicker than average ice. We did have early ice up in the Chukchi Sea compared to recent years, not compared to history, but compared to recent years, it did freeze up early up in here. And so this has had a longer time to grow. And then we do have some thinner ice up off the western North Slope coast here, thanks to very persistent east winds during March, has opened up some leads up there. So the ice thickness low there, but really quite an interesting pattern here. And while this is not, this isn't the same as what it is, the information you can get from on the ground or from the air, from an aircraft, or being out on the ice where that's safe. This is a relatively new tool that we have in our toolbox for assessing Bering Sea ice conditions. And I think from the Western science perspective, I think this is really important, because I think it's a good corrective. So many folks who are not familiar with the region tend to focus on the sea ice extent. And that's just one piece of the puzzle. The thickness of the ice, the quality of the ice, the stage of the ice is for people working on the ice, making a living on the ice and around the ice. That is just, or really more important from the individual's perspective than what the total ice extent is. So using that same information here, I thought, I've just been kind of amazed at how much open water we've seen pop up in March. So this is a little graphic that shows the areas in blue there are places that had at least 2 days with open water during March. I used 2 days, 1 day you could say, well, maybe the satellite, had a little glitch or something. Okay, 2 days can't do that. And you can see most of Norton Sound, that's not fast ice, had at least a couple of days with open water. Similarly, this huge area here from Nunivak Island up past now the YK Delta here, the Yukon Delta, had at least 2 days with open water. I don't have it here just in the interest of time. I did run this for previous years as well. And last year, this looked nothing like this. There was some areas here in Eastern Norton Sound that had 2 days or more with open water, but this did not. This is really quite remarkable and quite different than last year. So what's been going on? So this is kind of how I, in my Western science way, view how sea ice grows. So we start out, with this frazzle ice, first ice crystals in the water, and then depending on whether we've got rough ice or rough ocean, so wind-driven waves typically, or a flat ocean, kind of affects how the ice evolves. And what I keep coming back to is that in the northern Bering Sea, we seem to be stuck a lot this winter, certainly after January, where we keep getting this pancake ice, very little rafting or ridging evidence in areas where the winds have laid down. So maybe this nihilus, so this dark thin ice, only a few inches thick. And again, we're seeing very little in the northern Bering Sea. of getting to this rafting stage, much less any of this, the consolidation stage, and really not much of any size for ice sheets. So it seems to me, from my perspective, that we keep being stuck back here in the early stages. I don't know if there's anybody on the phone or on our meeting here that would like to opine on what's been going on. Why are we seeing this cruddy ice as we see in this picture here? Anybody want to jump in?
Maybe people will at the, if they're thinking about it now, they might want, and welcome to join in at any time, but maybe during the question at the
Sounds
end.
Rick, it seems to me that the persistent north wind has just been knocking it out of here, from Nome anyway.
Well, that certainly, I think, has a role. So here's some of the things that I came up with. First of all, I want to say there's probably more than one contributor to it, but the strong east and northeast winds certainly seem like they've got a role to play here. It's been, as we've seen, it's been really windy. Some folks have asked, is the water below the ice unusually warm? The best of my knowledge, and if anybody knows different, please tell me, but we have no real-time measurements of subsurface temperatures in the northern Bering Sea. There are, of course, some submerged instrumentation that will be recovered later in, over the summer, that will provide us with at least some point estimates of temperatures below the ice surface when that data is retrieved. And that'll be interesting to see, but at the moment, we don't have that. Have the currents been unusual? That's, of course, not unrelated to the winds. And one of the things that I wonder about, and this is just pure speculation on my part, are the changes that we're seeing in sea ice, in the shorefast ice, particularly with much shorter, generally less shorefast ice. Is that somehow implicated in this? Is the ice, the shorefast ice, not able to hold in the ice farther out in a way that it used to? I don't know, but these are just things that I thought of. So, of course, we've already seen some of this, and here's something. So this was this slide got added in here 1 hour before we started because the data just became available. But so here, just looking in Norton Sound for February and March from our climate analysis model, I plotted the relative strength of the east wind for February and March combined since 1960. And you can see 2022 really does stand out. Wasn't the strongest. This is just looking at the east wind component, not any other portion, just the east to west component. It's what this is. And 2000 was slightly stronger, but this year really stands out in recent years. A lot of east wind across Norton Sound, second highest here in this database back to 1960. So east winds, very unusual this late winter. How about the ocean temperatures? What do we know? Well, here were the ocean temperatures relative to the 1991 to 2020 30-year baseline, so the modern normal. This is how the surface temperatures averaged in October. So as we were going into freeze up, the cool colors are below that 30-year average. The yellows and reds are warmer than the 30-year average. And you can see most of the northern Bering Sea was cooler than normal, mostly not by a lot, but a little bit cooler than that 30-year average in most of the regions. So at least at the surface, we did not have really warm temperatures going into freeze up. And that, of course, is different than some years that we've had. If I showed this for instance, in 2019, even 2020, there was much more above normal on here than this past year. And this is reflecting basically the very cloudy, cool summer that we had last year. So at least going into freeze up, the ocean's surface temperatures were not excessive by any stretch, certainly not by the modern reference. So winds clearly were very abnormal. The east wind component, not just the average speed, but that east wind component that would serve to push ice out of Norton Sound was very unusual this season. All right, so that's what I know about ice. The last few minutes here, just run you through our what we have for outlooks for the upcoming season here. All right, one of the products that the Climate Prediction Center runs on experimental basis is a sea ice model. And one of the things that come out of that is when we're going to see open water for the first time. This was the model output that was made in forecast that was made in late March. So this is the most current. And I've labeled the bars here for your ease of reading and broken this out just by half-month intervals. And some of this is, I think, pretty clearly out of date already. Obviously, we have open water north of Nunivak Island already. I would be somewhat surprised if ice really lasted, if not just ice lasted, if near St. Matthew Island, we didn't have open water there until early June. That's probably not going to happen. But clearly, this particular model sees fairly marked loss of ice as we go through May, and only patches hanging around beyond mid-May, and really except for a few errant and likely wrong areas there in the south, and probably better forecasts there in the western Gulf of Anadyr, where the ice always lasts longest. This would suggest open water showing up most of the Bering Sea, northern Bering Sea, during the month of May, and then progressing northward from there, of course. How about ocean temperatures for the summer? Again, from our colleagues at the World Climate Service, here is the outlook, and this is showing the multi-model, so several models average together the departure of sea surface temperatures from normal for the 3-month season. And interestingly, you will see that the area of blue, so slightly below normal there in the central and northern Bering Sea, most of the rest of the eastern Bering Sea in that near normal category, within a ½ degree of normal, and then the warm water that's been over the southwest Bering Sea for a couple of years now, still there. If you were with us last spring when we did Straight Science, we saw something similar with a cool forecast of sea surface temperatures in the northern Bering Sea, and I kind of poo-pooed that, and I had to walk that back, because that actually did work out last summer. There was this cool water did persist, cool relative to normal, did persist in the northern Bering Sea most of the summer. So that's what the models have. The models are not indicating at the 3-month average here anything untoward as far as warm sea surface temperatures this coming summer. Now here's the just the month-by-month outlook, starting with May here. Temperatures are on the left, precipitation is on the right, and these are from the World Climate Service, and these are constructed the way we do these temperature and precipitation outlooks in climate world. So we're not forecasting absolute values, but rather the categories. So near, significantly above, and significantly below normal for both temperature and precipitation. Precipitation ones are there's no tilt in the odds in any of these here for Western Alaska. Temperatures are kind of interesting for May here. Does have actually the very rarely seen increased chances for near normal. That does not happen very often, at least along the coast and for Nome, including Nome. most of the region in that no tilt towards significantly above or significantly below. Little bit of a tilt towards warm there for Northwest Arctic Borough, and then poking down into the Eastern Seward Peninsula. But all in all, not too much anything big or dramatic here for May. For June, it gets even less informative here now. There's really no particular tilt for anywhere the land areas for Western Alaska. So neither above or below normal favored. That doesn't mean near normal is likely. It means the models basically don't agree on above or below normal. That gray area is slightly increased chance for near normal, mostly reflecting the sea surface temperatures that are being forecast. Precipitation, nothing on this whole map to tilt either to above or below. Oops. July. And here is the July outlook. Again, precipitation, nada. Left-hand side temperatures. Now we see that below average tilt doesn't quite make it to the coast, but over the northern Bering Sea as well as St. Lawrence Island. And of course, after last summer, we see cool and we think cloudy and rainy. The rain part does not show up in the precipitation outlook. That slightly increased chances for below normal temperatures could just be reflecting what the collective wisdom of the models think will be below normal sea surface temperatures. Particularly the fact that it doesn't extend over land gives some credence to that. But really, these are about as milk toasty of monthly outlooks as we would ever see. If we were doing this in Anchorage, you see it would look a little bit different. But for Western Alaska, I think the best guess is at this point, to be honest with you, we don't know. So that is what I have for you today. I realize I have chewed up the full hour here, but I do want to thank Gay and Alaska Sea Grant for allowing me to come to you tonight. So Koyanuk, and probably most of you on here are already on our Seward Peninsula Bering Strait Weather and Climate Info Facebook group. But if you're not, please feel free to join and get your friends to sign up too. So I'll shut up now.
No, not at all. Well, thank you so much, Rick. I mean, that was spellbinding as always. So while everyone's getting their questions, don't worry about the time because we're not worried about the time out here, but as much. So remember for the straight science audience that it's not easy to be a straight science speaker or any kind of public speaker, and show Rick some love in the chat box. Throw him some love there because thank you so much. It was spellbinding, and I don't know if that, I think I got it about the precipitation, but it looks like I just kept thinking sunny days after last year's cold, low solar radiation summer. I'm optimistic, but probably I'm reading that wrong. So I know I've got some questions, but I'm going to hold off. There is a question in the chat, Rick, and that is from Elizabeth Seiden. I wonder if salinity changes after several years of low ice. Oh, I wonder if salinity changes after several years of low ice could impact ice formation or contribute to degradation of sea ice from below. ... Higher salinity with a lower freezing point.
So I think that is a very interesting idea, and I wonder if that if salinity changes might be implicated in some of the things that folks have been reporting from around the region with what did the folks in Savunga have to say, Gay, that basically we never got out of the fall ice stage, that the slush was staying on the bottom.
Yeah, slush was staying on the bottom, and so it was an interesting, very interesting conversation for a different meeting. I was there for an environmental harmful algal bloom meeting, but we ended up talking about the ice because it was so incredibly amazing flying in. And that somehow we were still in like fall, like we really hadn't experienced as far as that stage where the ice is on the bottom, sticking on the bottom before it comes up as slush. And that got me really full of questions about what, Western science versus, and I have a lot of questions about that versus some of what people see near shore and in this region. But it seemed like people were saying, my best interpretation was that the ice was remaining in a fall stage, and that seemed really unusual. Like we hadn't really had winter properly, ice-wise.
And, certainly, salinity changes, in that frazzle ice, subsurface. I think those are great. Those are really good points, Ebert. Thanks for mentioning that. And there are models of ocean salinity, but again, they're on operational models, but they're on the global scale. They're not really, as near as I can see, usable for our area of interest, especially in the winter with sea ice. If we were in Hawaii, they would potentially be more informative, I think.
Did you see her second comment about the Aleut community of St. Paul Harbor monitoring has shown increasing salinity for the last 8 to 9 years? Very interesting data set.
I was not aware of that. Thank you.
All right, and Jenny, I see your hand up. Why don't we switch over to, oh, I've done the greatest faux pas of all. We have callers on the phone. My apologies to the callers. If any of the callers have a question, please feel free. Oh, maybe we lost them. We had several callers. But anyway, if anyone calls in, speak up. With that, sorry, Jenny, I got sidetracked. You have your hand up. Go ahead and let's hear your question. Good to see you. Oh, you're muted.
Sorry. Hi, Gay. Thank you so
Hi.
much. And thank you, Rick, for a wonderful presentation. My head is so full with a lot of Arctic study today. I'm down here at the Arctic Encounter Symposium in Anchorage this week. And, talking about data disparities, particularly with regard to sea ice extent, has been a big topic today. And I had a question for clarification about, Rick, you said something about a new tool being able to give kind of fresh perspective on the thinning ice sheets in the Bering Strait region. I'm a little confused about what that tool is. And then also, you also mentioned that the 12 years that we have to look at this kind of data that has been made available so far, you wouldn't rely on it in that kind of time span. I'm wondering, when does a time span become worthy enough or valuable enough to make projections or predictions or any other kind of scientific theories or hypothesis? Thank you.
Yeah, thanks very much. So the data set that I'm using, and as far as I know, is the only operational data set available for sea ice thickness that works with comparatively thin sea ice like we have in the Bering Sea in the winter, I'm using the technical jargon here. It's the combined SMOS Cryosat-2 sea ice thickness data that's available from several sources. I grab it from the Alfred Wegener Institute in Bremerhaven, Germany, but it's available elsewhere. And that combines the Cryosat-2, which is good. It's radar derived thickness, but it's best for ice that's more than about a meter and a half thick. Whereas the SMOS doesn't work with ice that thick, but is better for ice under a meter thick. And they have developed a way to merge those two data sets. That starts in the fall, late fall of 2010, and is continued. So that's what we have. You know, in climate world, a standard period of record to derive statistics from, like departures from normal, is 30 years. There's nothing magical about that, except to the extent that in statistics, you know, once you start to get to around 30 or more, the things like the averages, things like the variance in a unchanging world, that starts to become stable. That we don't live in an unchanging world, and that's why I say that even if we had longer period of observations from this sea ice thickness data, that it might be less informative, in the sense that the ice conditions, the ice thickness, is so different now than it was in the late 20th century. I'd still like to have more than 11 years going into this, but you know, if we had 25 years, that would probably be, given the pace of change, that would probably be good. Does that answer your questions?
Yes, it does. Thank you so much. Very helpful.
Thanks.
All right. And we have questions. I don't know, Rick, if you want to stop share so people can maybe get a bigger view of you. And there is a question from Peter Lowry with the Gnome Nuggets. He has two questions. The first one is, you said, quote, near normal months are sometimes composed of a lot of not normal days, end quote. And I was wondering how that impacts modeling, and when does it mean you change the way you model? That seems like a hard question to me, but good question.
Okay, well, no, it's a very good question. So, of course, sometimes, you know, weather is steady state, and okay, it's warmer than normal. It's been warmer than normal most of the month. Other months, like for instance, we saw in December in Western Alaska, started out cold, big, tremendous storm, got cold again for a few days, and then the blowtorch and fire hose got turned on. So temperatures wound up pretty close to normal. Precipitation, different story. So the short answer is, for things like our climate models, like what I was showing there for May, June, and July, those are actually, they are very much like weather models, in the sense they start and then they just go forward, and they're actually outputting information every few hours. So they actually are running at a even below daily scale. So in that sense, the day-to-day variation is built into those. Now, whether they get it right or not is, of course, a different question. But in that sense, the potential for big swings in a month are built into those, what we call those dynamic models. They're really just glorified weather models that, instead of being rerun every 6 hours like the Weather Service operational weather forecast models are, these run for most of them run out 6 to 9 months. And there's multiple flavors of these as well. They're not just a single run. So that, in that sense, that is taken into account. Things like what I showed with, okay, how have La Nina winters, how have those worked out for temperatures in known? Those, of course, are only using the monthly averages. And so the day-to-day variability or the flip-flops are not being accounted for in that. And I suspect the answer to your question is, how will we change the modeling? Once old fogies like me fade out of the scene, that those dynamic climate models will become more and more, and what these statistical approaches, so using the past to forecast the future, those will become of less importance. I've certainly seen that in my career. 15 years ago, we had nothing but these using the past to forecast the future. And we've already seen a big decline in that, and no reason to think that that will change.
Hope that got Peter's, I'm sure it did. The second part of his question was zero water measurements in Western Alaska these days regarding snowpack. Why is that?
You already know the answer to that one, right? So there have never been very many. When the Weather Service stopped doing anything other than maintaining the automated weather station at like Nome and Kotzebue, those went away. There are a handful of automated stations that the Natural Resources Conservation Service runs, those snow tells. The one, for instance, at Johnson Camp, east of Solomon, we got lots of use out of during Iditarod with the high winds. And they do have snow depth measurements on there. There's one near Rocky Point down towards Gullivan, and there's one at Pargon Creek up in Death Valley. But none of those have snowpack water measurements on them. They have snow depth, but in high wind environments, what a one single point right below the sensor, the snow depth is, tells you exactly nothing about the water content. We desperately need snowpack measurements. And when I did this presentation last year, I even included a couple of slides. NRCS is willing to provide the equipment and training if any organization in Nome or Western Alaska wants to take this on and do, once a month measurements in March 1st, April 1st, May 1st, that we can do that, and we'll have one data point or two data points, however many organizations want to do this. Once it's set up, doesn't take much time. It would be great to do that. If you're interested in that, give me a shout. But at the moment, there are truly no real-time publicly available measurements of snowpack water equivalent anywhere in Western Alaska. The westernmost places we have those measurements right now are Galena and McGrath.
Good question. Anyone else with questions for Rick after such a great presentation? Rick, I have a couple questions, but I just want to make sure I'm not jumping in line. Nothing in the chat either. So you got clap from Dean Stockwell. Thanks, Dean. So on Rick's behalf. So my question is, you had mentioned something in the talk about 2012 was one of the most extensive ice years. I think you were saying it was the first time the ice had gone all the way down to the Pribs, St. George and St. Paul. But for me, I remember it, yes, it was most extensive year, but I always thought 2012 was the year that it was least, it retreated so high. It was record breaking. By July, the ice was the Arctic Ocean was sort of really scary looking because a giant piece of it was missing. All the ice that should have been up there was missing. And it was weird because that was also an extensive year. This was finally an extensive year. I think you said not since 2012. Is anything going to surprise us and the ice is going to go? Is there anything that was going on in 2012 that might make that happen? I wonder, here we're thinking, oh, well, the ice is so good, but they already thought that in 2012 and then it zinged right up, way up north.
Yeah. So it'll be interesting to see, of course, 2012, was an extensive ice year in the Bering Sea, but at least in historical times, the total amount of ice left in the Bering Sea in September, we know will be zero. That will contribute nothing. And in 2012, of course, we had that Arctic hurricane, that very deep storm that within a week in August wiped out a large chunk of ice. It was thin, it was very dispersed, and that Arctic hurricane came along and chewed up a whole bunch of ice. We don't know if something like that will happen. What we do know is that ice in the northern Chukchi Sea. So Utqiagvik northward is overall either the same or thinner than last year. We don't see as much of that big, thick multi-year ice having worked down from Northwest Canada into the Beaufort Sea and northern Chukchi Sea as we had last year, and that contributed to the ice hanging on in those areas longer last summer. So what we know for sure is the Bering Sea is going to contribute nothing to the September ice extent because it'll be zero. It is a little disconcerting to me to see, you know, we have had big polynyas there west of Utqiagvik and all the way down past Point Lay. Depending on how the ice goes, if we really do get ice melt in most of the Bering Sea during May and we get the Alaska current going again, it could be an interesting year.
Thank you, because there is concern, of course, with the temperature of the ocean getting warm and some of the things that will happen with that, the lack of the thermal barrier, and then the southern Bering Sea ecosystem comes up again heavy, or we have types of algae that we don't want to see grow that might like to grow. So it's just a lot of questions about the summer ahead.
And that's a big concern that I have with all the open water we've seen in March. Okay, at the moment we've got a bunch of thin ice, got a weather pattern change is on the way to the northern Bering Sea even as we speak, and going to bring south winds in, much warmer temperatures, and you know, I'm pretty confident we're going to see large areas of ice are going to fold like a cheap 10.
And when is this weather coming in? Just curious.
Next 2 days.
Next. All right. Circus is going to leave town if the cheap 10 folds up really quick. So
Right.
Thank you for that heads up. Dean, you have your hand up.
Yeah, nice talk, Rick. A lot was mentioned about things that would kind of erode the ice. And, you know, you talked about water temperature, you talked about atmospheric temperature, you talked about salinity and winds. Observations from your open water patches slide, you showed basically Norton Sound being kind of cleared out by strong easterlies. And you showed the area down by Bering Strait being impacted by winds coming out of the north. And earlier this year, all of the shore fast ice, the fast ice up off Utqiagvik was blown out from strong easterlies. So I think this, you already talked about the impact of the winds this year. Are there any observations from people locally that you've heard about the ice algae cover on the bottom of the ice? Because that's going to be a resource that's lost to the benthic community if that hasn't had a chance really to form.
Gay, can you speak to that?
Sort of. I mean, there is comments coming in from different communities in the region that because crabbing and fishing through the ice and crabbing through the ice right now are ongoing. And people are mentioning here and there, I mean, it's just that the ice algae seems to be less
Okay.
on the bottom of the ice.
Yeah, that's what I
don't
kind
know.
of figured. Yeah. But the other thing is this coming year, looking at the models, La Nina is supposed to continue for a little bit. Isn't that correct?
It's hanging on.
Okay. Thank you.
So I guess one thing I didn't mention that, and I'll take this opportunity to do so. So, you know, I think we can make the case that really the remarkably persistent, strong, at times extreme east winds in Norton Sound, you know, that's responsible for some of what, or the most of what we've seen in Norton Sound. But I don't think that we can invoke the winds to explain, you know, what the ice conditions here off of Gamble. It was not relative to normal. It was not nearly as unusual in this part of the world. And yet we saw the pictures and the video of just very low quality ice in here in late March. And I don't think the winds work as an explanation here. And this is what leads me to believe that there's something else going on. And maybe, you know, in different parts of the northern Bering Sea, different factors are predominant. But yeah, east winds work as an explanation here. I don't think they work over here.
If you want, as an added bonus, we have a little video, very short video clip from today, from noon, from the helicopter to Diomede. So if you want to see, I don't know if people want to see that, but curious if we had very cold temperatures this morning. It was -13 out here in Dexter. And that was, I figured, oh my gosh, this is part of the wild weather ride. Let's go down, let's go back up again in tomorrow or the next 2 days.
You're going to be above freezing by Sunday.
Wow. Okay. So I'll just put it on if people are interested. It's just short, but it shows you right now, even with that cold weather, what it looks like. Oh, I got to share screen. You can see that. And this was from noon today. That's Fairway Rock. The helicopter's heading northeast. This is Big and Little Diomede right there, panning east. And you can describe it better, the ice types there, than I can.
I mean, look like we got some Nillis there, but I mean, there's just very little rafting. Look at that. I mean, there's a tiny bit, but it really, that is crap ice for April 7th in the Bering Strait. Sorry to get technical there.
Yeah, no, that's okay. It sort of looks that way. And we have a lot of ecological things that are going to happen here really quickly. And we would like to see some strong ice for all the birth that has to take place, that will be taking place in this region. So. All right. And when you say the winds, this is from the chat, when you say the winds were not unusual, is that both strength and direction?
Yeah, that's a good question, Ebert. I'll have to look at that. The strength, from that graphic showing the relative rank of the wind speeds for December through March. So St. Lawrence Island was kind of on the western fringe of those higher winds. So wind speeds were above normal, but not wildly so. I will have to investigate. For instance, was there more north wind than usual in that area? And I'll look at east winds too. So the directional component I haven't looked at yet. We did see though that the strength was above normal, not wildly so for that part.
My last question or comment would be, when I used to always go to the National Weather Service ice maps that they generate every day. And, this year seems to be even more to my mind when you look at those and then you're actually in an aircraft or you're on the coast, they're not matching up very well. It just looks, they have that blob of red. Is that because, and then you go there and it's actually, no, it's not all 100% or not even 9/10, not even close to 9/10. And are they going to switch? Hopefully they're watching how this mismatch, or maybe they're not, I don't know. But do you think that is there any talk of somehow making those maps more?
Yeah, I'm of course not
thing?
privy to what the Weather Service is discussing, but I mean, I know that a number of the ice analysts are on our Facebook group, and so they're seeing what's on there. So both what I'm posting and even better local obs. One thing that someone did point out to me, and now off the top of my head I can't remember. So the Weather Service Ice Desk every day produces the two charts: the ice concentration graphic, which is painted red in the northern Bering Sea at the moment for the most part, and it often seems less informative. But also they produce every day that ice stage graphic, and that has looked that has looked, they've been showing lots of areas of
Okay.
first year new ice and first year thin ice. I'm not aware of any online archive for that ice stage graphic, but and I don't look at that every day, but it does seem to me that that is showing new ice and thin ice more in the northern Bering Sea than in, say, last year at this time. But that's just my occasional look and impression. So to some extent, I mean, the NWS forecast analysts are aware of the conditions. Some of it is the limitations of the product and the scale. Nome to St. Lawrence Island is just a tiny part of that map. So I think that it's a good lesson for folks in the region and folks interested in the region. We really have to use all of the tools that we have available. What government agencies are providing, what is available online now, things like the high resolution satellite pictures when we can get them, when the skies are clear. The ice, that's new ice thickness products. I think the lesson of our changing environment is we need constant vigilance in using all the tools that we have, from the latest and greatest of Western science to, millennia honed indigenous knowledge.
And thank you very much. And the last thing I wanted to say was, truly last thing I wanted to say was, for this talk, was that when you showed those tremendous storms for the people from the region, when Rick was talking about that storm series in December where we had 90+ mile-an-hour winds, please know that we had large vessel traffic coming through down from the north, as well as trying to heading south, as well as heading north. We had some very large ships on the Russian side coming out of the Northern Sea route headed south right into that storm, and they had a horrible night, but they punched through it and kind of rode it out and kept coming slowly. But it does give you something to think about in the dark of December, to have those kind of storms and those kind of vessels, and we didn't have ice. Just gave you the willies, actually, from me. But anyway, with that, next week, we're going to have, for a straight science speaker, we're going to have Sabrina Garcia. She's with Fish and Game, and she's going to be talking about salmon sharks, which kind of is riding on the heels, Rick, of your talks of the great change in the ocean, the great change of the ice. And now we're going to start having our first straight science talking about the movement of sharks. So tune in next week.